Yesterday we started chapter 2. We're doing increasing, decreasing, intervals, constant intervals, and it didn't say my work. I don't know why. Oh wait, yes it did. It's on this one. Bam. Okay, we were doing intervals of increasing and decreasing and constant, and then I was telling you that in my math lab they want a comma. They don't want the union. So I'm going to fix that right here. They want a comma. Draw an arrow, put my math lab. Union is, they want it with domain and range. With increasing, decreasing, and constant, they just want a comma. Remember we talked about not to think of this as a coordinate point, but to think of it as it's running in a decreasing fashion from the x value 3 to the x value 5. That's why it's called an interval notation. We'll always read it left to right. It helps if you highlight along the x-axis what's happening, and then you just translate that to your intervals. Then we looked at relative max and mins, and then we talked about the fancy way to type it in. They want you to state the y value at what x value when you're discussing max or min. And then we had a complicated one to see how you do with typing it in the calculator. Remember Zoom Calc, and then you have to distinguish between which one you're looking for. I'll put a question mark there. You know, is it a max or a min you're looking for? And then you answer the 3 questions. You can't look at them at the same time, is what I mean. Yeah. You'll have to do one, get the answer, and then you have to go back to second calc to do the other one.
Can you go back to that?
Yeah, which one? This one?
Yeah.
Yeah. The next one. What is it they say? Don't let it beat you. The next one is a word problem. Yay! Are you excited? 2 nurses, Kiara and Maddie. I don't know how to pronounce that. So, Matthias. See, this is when I read word problems, I think, let's go K and M, so that I can focus on the math and not try to get hung up on what I can't pronounce. Matthias. 2 nurses drive away from a hospital at right angles to each other. One nurse's speed is 35 miles an hour, and the other nurse's speed is 40 miles an hour. Express the distance between the cars as a function of time, then find the domain of the function. So when you're first reading this, I'm sure your first thought is, I really don't care how fast they're going or what direction they're going, but we do have a math problem in front of us, so let's look at it. If they're going opposite directions at right angles to each other, what geometric shape is implied here? They're going opposite directions with right angles to each other, so and we want the distance between them. Yeah, there it is. Yes, all of that was right. All right, so I'm just going to draw my triangle like that. There's my right angle. They started at the hospital, so I'm labeling this as H. One of them went in one direction. How fast? 35. So I'm going to say Kiara is going in this direction. Now she's going 35 miles per hour. Notice that the question is saying express the distance between the cars as a function of time. And then they give you this. This is huge. They're telling you, name your function d of t. And then they're telling you right here that your input is t, which is usually your x. So they're telling you your function's going to be called d of t. Your input is t, which means you should be able to write expressions using t here. So she's going 35 miles per hour. We don't know how much time has passed, so this would be 35t. Mattia's, yes, all right. Mattia's going 40 miles an hour. What would this be? 40t. Express the distance between the cars. So they've left the hospital. Now one of them is over here, and one of them is over here. So the shortest distance would be a straight line between the two, right? Which happens to be what's called the hypotenuse, and that means we will be pulling in the Pythagorean theorem here. Now the hypotenuse is what we don't know, correct? And it would represent their distance apart, correct? Yes? As a function of how much time has passed. So the explanation for why these letters go here is, this is the speed, we don't know how much time. This is the speed, we don't know how much time. This is the distance between the two cars in terms of how much time has passed. So now, because it's a right triangle, it is simply a Pythagorean theorem problem. Let's make a note. Reminder, what is it? Do you remember?
A squared plus.
Very good. Okay, do you remember the restriction? One of them has a restriction. One of the letters. It's C. You had me geometry. That's, yeah. Okay, look. C, I'm going to draw an arrow. C has to be the hypotenuse. Every time. Doesn't matter how you plug A and B in. Doesn't matter how you plug A and B in. I love it.
Huh?
Howdy.
Send that to you?
Yeah.
Okay.
Howdy.
I like you did.
Thank you. I appreciate it. All right. Now we're going to plug in. These are the legs of the triangle, and then this is the hypotenuse. So those are going to go in place of A and B, and then D of T is going to go right here. I'm going to change to red, which means what, y'all? Okay. Look. You might think, well, how is that wrong? Take a second, don't holler it out yet. Look at it and think. All right?
First of all, the T's are the only thing that are square.
That's the problem.
And also the C is square.
Right. If you plug the 40t and the 35t in just right there, and you just copy the square, when you look at it, the 40 would stay as 40 and the 35 would stay as 35, and that is inaccurate, okay? Because there is, even though this is one term, there's two parts to the term, right? There's a 40 and a t. So it's supposed to be 40t times 40t. So now you can see where the 40 should be squared. So all I have to do to tweak that would be put, thank you, parentheses. But I do need to erase it because it's all in red. Okay, so I'm going to plug in 40t in parentheses, 35t in parentheses, whoops. And then this is d of t. Now that is just the expression d of t, right? You don't have, when you put that's a name. It's like one big variable, like one big fancy, that's supposed to be a y. It's like one big fancy y. So you can just put squared there. It doesn't mean you're squaring the t. It means that this expression, this name, right here is squared. And I'm going to show you what we're going to do with that in just a second. Let's go ahead and evaluate 40 squared and 35 squared.
1600 and
Go ahead and add them too.
1,825.
You're 2,000, right?
1,800.
You-
2,800.
When you add them, though, go ahead and add them.
Oh, yeah.
Yeah, you're good. 2,825 t squared, right? Since they end up both being t squared, they're like terms, so you can add them together. So this right here is still d of t squared. We want d of t to be just, we want d of t squared to be just d of t, so what would we do? Square root both sides. That will get rid of this, which is why I was saying, like, don't square the d and the t, because that's a name. That's not d times t. That is a fancy y. Okay, so then, because this is one of those word problems where we're talking about distance between two cars, if I said to you, oh, the distance is the square root of 2,825, can you interpret that? That doesn't tell you how far apart they are, right? So we do want to actually get some type of understanding for how far apart they are. You can take the square root of these individual pieces here. Let's go to something simple. Recall, if you had the square root of, I'm going to make it simple, like 4t squared. That would be the square root of 4 is 2, and the square root of t squared is t. Okay, so right here, you can go to your calculator and take the square root of that ugly number, and we can get the expression for it in terms of decimals. And then the t squared would just become t, right?
Do you want us to round?
You can actually leave it right here. If I told you to express it as a function of time, and I just wanted the equation, you could leave it here and say that the function is the square root of this. You can write it that way, that's a t, which is the same thing we just had, right? Or you can take the square root of the t squared and put the t in the front or at the end. It's up to you on how you're comfortable leaving your answer. The point of the question is, give me an equation, a formula, to represent how far apart these women are based on how much time has passed. So you've done that now. You've written an equation based on the time that passes, and it's in function notation. Now, we do need to say the domain. Domain means what?
All the x.
All the x values. What is x referring to? What is the letter for x? Okay, so we were talking about t means time. So what type of numbers are not allowed here? Negative. Does that make sense? So if I said to you, what's the domain of this function? And we're talking about time passing, cars driving, how far apart they are, you would say to me, well, it's referring to time, so it could be 0 to positive infinity, right? So your domain, now put it in terms of numbers. T has to stay greater than or equal to 0. Because you can't have negative time. So you might want to make this note on your paper. You can't have negative time, which is exactly why the domain there is staying at 0 or higher. You'll notice the question never said solve. Do you notice that? It doesn't say solve for anything. It doesn't say find the value of, find their exact distance apart when this much time has passed. It doesn't say that. All it says is, give me an equation to represent it. That's where I think some people struggle with this type of question because they want to actually solve for something. They're so used to solving for a letter. This is not a solving problem. This is, give me an expression and then interpret to me what's allowed to be plugged in based on the context of the problem. Does that make sense? Yes. All right, go to the next word problem. You can put a big old fat star next to this one or something because she's on the test. She's definitely on the test. All right, we have area of office space. A community college has 30 feet of dividers with which to set off a rectangular area for a student testing center. If a corner of the math lab, not the other. If a corner of the math lab is used for testing, the partition need only form two sides of a rectangle. Express the floor area of the testing center as a function of the length. Find the domain, graph the function, find the dimensions to maximize it. There's a lot going on here. Well, mine fit. But that is why also there's all that extra space. So don't try to put it all in the box. But it's not as much writing as what you think.
Is that in our packet?
No, we're on the same one.
It's the one, it's the 9798.
That one. There you go. All right, so let's look at it. We've read it once. Let's go through, read it again, and let's underline, highlight, take notes. Let's try to visualize what we're looking at here. You're at college, there's a math lab. By the way, pretty much every college I think has a math lab, and you need to go there. That's where you actually can get help for free. You don't have to pay for it. I used to work in the math lab at, what's it called? UTC. I used to go to the math lab at Kennesaw, and that's where I met some of my best friends that I'm still friends with to this day. Math nerds, I know. Okay, a community college has 30 feet of dividers with which to set off a rectangular area. If a corner of the lab is used, the partition needs only form two sides. It would be like me saying, I want this to be my testing area, so I'm going to put dividers up here and here. Does that make sense? Y'all hot?
No. Yes.
No.
No.
Yes.
It's the flannels.
So honestly, perfect.
Yeah, I'll say it's good right now.
This is the everything I'm getting all day.
Well, we just got popped in on again, so, and I don't know, the window's shut, so I can't open it. Is that, I think so. That's what I was wondering.
Well, he's walked around every time.
Somebody's here. He said somebody's visiting. All right, so imagine y'all can take your flannels. It's all right. I totally understand right now. It's okay. You're
Oh,
okay.
look at her shoulders. Oh, no.
Calm down.
I'm just gonna be your eye.
I don't mind when you're hot. It's hard to focus, so I totally understand. As long as we're covered, you know. Okay, we got a corner of a room. I'm going to put partitions here, and I'm going to put partitions here. So I only have how many sides to worry about? Two. Okay, so let's draw a little visual. And this is wherever you can find space, maybe above the problem. But think about in the corner of a room, the walls are there as the two sides that I don't have to worry about. I need a partition here and here, right? How much of the dividers, how much do I have? Like total, how many feet in dividers? 30 feet. This is huge right here. This is telling me that how much do you have to work with total? You have 30 feet. What shape is it? Rectangle. Don't draw a square. It's a rectangle. They want us to express the area of this shape. So what's the formula for area of a rectangle? Length times width, just area. Perimeter's coming in though. So the area of a rectangle is length times width, and they want it as a function of the length. This is telling you right here. Remember in the last problem it was d of t. D meant distance in terms of time. This is express the area in terms of length. So this means we have to write a function for the area in terms of the length. So this is A of L. Does that make sense? Now we have to look at it and ask ourselves, what can we deduce about this rectangle with what they've given me? All they've told me is you've got 30 feet to work with, right? So now imagine, come over here, imagine to yourself, always start small with math problems. If I used 10 feet in this corner to block it off, I would have 20 feet over here left. Does that make sense? If I used 15 feet, I would have 15 feet left. That's what you need to ask yourself at the beginning of the problem, because if, let's say, you go through the whole thing, and you come down here and you say that the length is 18 and the width is 15, it doesn't make sense because you only have what? You only have 30 feet. So use these little, like, okay, think small to yourself as checkpoints as you're working. Okay, so we know that we want the area. We know we have 30 feet. So we're going to write a function of L. If this is the length, change colors. If this is the length of the rectangle, if the length is 10, you said the width would be what? Okay, if the length was 5, the width would be 25. How are you getting it? You're subtracting it from 30 because they have to add 30, right? So if the length is L, then the width would be 30 minus L. Does that make sense? Y'all see how I got 30 minus L? It was the same concept that you did when we were thinking small. 30 does need to be in the front because it is the bigger number, so make sure you don't switch those. So now you have an expression for length, you have an expression for width, you know the formula for the area of a rectangle, and now we can set it up and write our expression, which I think is part A. So let me close this. All right, so A. Express the floor area of the testing center as a function of the length. So A of L, which is the name of our function, is going to be length times width. Well, my length is L. What's my width? 30 minus L. That's it. I think in my math lab they want you to distribute to enter your answer. So right here is your function. I'm going to put or underneath because we're going to multiply. So that would be 30L minus L squared. That is the function for the area of this scenario based on the length of the lid. The length of the length. The length of that one side that you set up your partition. I got it. I'll figure it out. Now it says find the domain. Okay, domain means what x values are allowed to be plugged in. What are we talking about here? We're talking about partitions setting up in a corner, right? So what can we not plug in? Can we realistically plug 0 in? No, because that wouldn't make sense. Then you would have no length, right? Can we plug in negative? No, that wouldn't make sense because you can't have a negative length. So we can plug in positive numbers, correct? Can we plug in any positive number? What number are we kind of capped out at? Yeah, if you plug in 30, now you're going to have a width of 0. Does that make sense? So you have, on this particular problem, you're going to have to actually think to yourself, there's a small range of numbers that I'm actually allowed to plug in here. Now, realistically, would you have a length of 0.5? No, but it is allowed to be plugged in, and it would provide a width. It's not ideal, but it is allowed. So when I say that the domain is between 0 to 30, you don't want to argue, well, no one's going to put a partition 1 foot and then 29 feet the other way. You're right, no one is, which brings us to the last question that says, what would maximize the area? Which means if you have a 1 by 29 or a 2 by 28, see where I'm going with this? Or a 3 by 27, notice that the shape is creating more room. And I'm still playing with the numbers that add up to 30. And that's why D says, so what dimensions would create the nice big rectangular space that would allow more people to sit over there and test? And that's what we're looking for, the maximum of this. Starts with a cube. Quadratic. Let me erase some of these. Okay. So our domain here is, it's going to stay between 0 to 30. That's one way to write it. I think I wrote it in interval notation from 0 to 30. C says graph the function. Go to your graphing calculator. Type it in y equals. Type y equals, you're going to type 30x minus x squared. When you get zoom 6, what do you notice? Can't see it, can you? Okay, so now what we want to do is try to find the curve. Let me show you a new button that you've not seen yet. Hit zoom. Arrow up. You see 0? It says zoom fit. Right there, 0. Type 0. Zoom fit is not always perfect, but it gives you a better starting point when zoom 6 doesn't work. So now you can kind of see, okay, the curve's going that way. So you should be intuitive enough to know that this is going over here, right? Okay, so I need to figure out, I need to extend my, what is this? X-axis max. And does any of this matter? No. And I really don't even need this much here. I need quadrant 1, and I need the X-max extended. And I can kind of already see it's going to top out not far away. So I also need to extend the Y-max. So now you're going to go to your window. Go to the window. And let's play around with this. We want our X-max to go further out. I usually go farther than I need to, and then I come back. I also like to change the scale so that there's not a million little tick marks. I'll change it to usually 2s or 5s. That means it's going to count by 5 instead of counting by 1. Notice the Y-min is way low. I don't even need all that. I'm going to go to -10. The Y-max is already 200. That, remember, the Y represented what in here? Y represents, well, the X represents the length. The Y represents area, which is why it's at 200, because if you think about it, what's 15 times 15? 225. Remember when I said, imagine if I had a wall that was 15 here, that would leave how much over here? 15. And what's the area of that? That would be 15 times 15, which is, so I need to definitely change my Y-max where I can see past 225. So I'm going to go to 250. Now, that's a really big range, -10 to 250. I'm going to tell it to count by 25s. I don't want a million little tick marks. Let me show you what I mean by that. Look. Well, you can't even see them, but so it really didn't matter. I usually change it to where there's not a ton of tick marks, but it doesn't matter here because it ended up being nice. Hit graph. Now you can see it. Right? The question says, find the dimensions that would maximize the area. They're telling you, find the max of quadratic. Well, we just did this yesterday. See if you remember the steps to type in your calculator. You're finding the max of that curve. It's going to ask for a left bound, a right bound, and then a guess. So the max is what? The max, what was the Y value? 225 at what X value? It was 14.9999999, which is 15. Now let's interpret it. This should make complete sense because these numbers we're familiar with. I said to you, if I did 10, I'd be left with 20, right? Now find the area. 10 times 20 is 200. Okay, if I did 15, and then I'd be left with 15, find the area. 15 times 15 is 225. That's more area, right? Can I go any longer than 15? If I go longer than 15, this is 5, 10, 15. Mine's counting by 5s here. 5, 10, 15. If I go longer than 15 in the length, what is going to subsequently shorten then? The width. because I only have how much to work with? 30. So if I go 16, you might think, ooh, 16 in the length will work. No, because now your width is only going to be 14, and 16 times 14 is going to be less than 225. No, it don't. I knew it! I was trying to avoid it! And it's in the video! I love you. I hate you. I love you. Alright, anyways. So let's interpret it right here. Let's make a note. Max area of 225, what was this in feet or yards? Feet. Area is square footage. When does this occur? When the length is what? You just found it. When the length is 15 feet, which means the width is also 15 feet. I think in my math lab you're going to have to answer whether it is feet, square feet, cubic feet, and so on. I think that's one of those drop-down menus. If you just took 2 dimensions and multiplied them together, your answer will have a square unit. If you take 3 dimensions and multiply them together, your answer would have a cube unit, which would be volume. So a lot of people are uncomfortable with answering those square units or the cube units, and I think it's because no one's ever looked at you and said, it's just a matter of how many numbers you multiply, because it's dimensions. If you're doing 2 dimensions, it's square footage. If you're doing 3 dimensions, it's volume, it's cubic feet.
Three-dimensional shape.
Right. And I don't think we're nowhere near that, so we're good. Y'all should be able to answer that every time. Alright, look at the next one. So now we're getting away from word problems a little bit. You'll be thankful. Now we're going to, do you know how to read a piece function, evaluate it, and then tomorrow I'm going to teach you how to graph it. Alright? Look at this. This graph has 3 pieces to it. It's got a quadratic, it's got a random point, and then it has a linear expression. In order for it to pass the vertical line test, which is that where you draw a line anywhere and it only crosses one time, you might think, well, what about right here? But what do you notice? Open, open, that's the only one closed. So it still passes. In order for piecewise functions to pass the vertical line test and be functions, you have what's called your domain restrictions. This is, I'm going to write several things. These are called your rules. Another way to think of it is your domain restriction. That is a fancy way of saying what you're allowed to plug in for x. That's a fancy way of saying it. This part right here is your actual graph. This is the function itself. This is the equation. And then this is the rule that tells you, hey, from this graph, I only want you to plug in numbers less than 2. That's how you interpret it. For this graph, I only want you to plug in the number 2, which means there's nowhere to plug it in, so that's why it comes out as a single point, right 2 up 6. This right here, let's make a note on your paper, and this will come up in another problem. Maybe highlight it, I don't know. This particular piece is just a point. And they're telling you the x-coordinate is 2, the y-coordinate is 6. It's just a point. It is not an actual line, curve, anything like that. It's just a point. Now, I don't like this particular thing here, so we're going to actually mark this out. Notice it says and. I want you to write it like this. Oh, wait. take the or equal to. Right at that. Remember when we did compound inequalities? And we said that if the x is in between two numbers, it's a lower and an upper bound, which means in this case you always read it from the x. For this particular function, you can plug in any number you want that is greater than 2 and at the same time less than or equal to 6. That's how you read that. Right here, with your graph, how many pieces are on this graph? There's 3. How many pieces are in the equation? 3. Look at the relationship to the domain restrictions, okay? The first equation says you can plug any number less than what? 2. This is where having a highlighter would really help with your graphs. Find x equals 2 and drop a vertical with a highlight. And now it said less than. So right here, this whole piece, like this whole section, is x is less than, it's x squared. What's the equation? X squared. Notice right here it says y equals x squared. This is x squared when x is less than 2. This point here is that middle equation. And then look at the next part. 10 minus x is from 2 to what? So 2, 3, 4, 5, there's 6. Drop a vertical. So from here to here, it's 10 minus x. So you're looking at the graph and you're sectioning it off. Now this one random point, this was the point, I'm just going to draw an arrow, this was the point 2, 6. It's just kind of like a weird little, hey, wait a minute, just drop a point there. Alright, so we have 3 pieces. We have the rules and restrictions. You will notice they never overlap. Because if they overlap, it's not a function. Something's wrong. So then you come to your graph, you compartmentalize it. That means create compartments. Think of lunch trays. Think of a man's brain. Sorry, guys. It's true. Y'all are compartmentalized when you're wired. We are spaghetti. What you did 9 years ago to the day is going to come up tomorrow, right? But men are like, nope, that's in that compartment. Leave it alone. Don't bring that up. Okay, so think of a spaghetti. Wrong one. Think of a lunch tray. Compartmentalize. You got this section is for this graph. This one random point is here. This section is for that graph. Does that make sense? Okay, which brings us to this. Here's another one. Let's understand it. These are our rules. This is what you're allowed to plug in. Now notice here, does this say x equals 1? Flat out x equals 1. No, this is an inequality, so don't you dare say this is a point. It's not a point, this is an inequality. There's a difference. The one on the last slide straight up said x equals a number, which meant, hey, you just have a point here. This is saying you're going to shade less than or equal to 1 at y is 2. That's how you read that. Then we have this equation, x, and it's for x is greater than 1. Here, let's see, what's it ask? It wants us to evaluate. Okay, so here's what I want you to do. Coming over here, beside each rule, I want you to draw a little inequality on a number line. This number here any number listed in the rules are called critical points. And that's because there is something happening here, which is why it's called critical. It's critical, you pay attention at this number because something's happening. So notice they have the same critical point, right? So I'm going to make my number line up. This one's 1, this one's 1. Now for this first one, this says I'm allowed to plug in x is what? Okay, so I'm going to graph that. That's closed on 1 and that's shaded this way. Right? What's the next one say? Just greater than. That's open and shade that way. Now, come right here. This says evaluate. Let me show you how to read it. Evaluate the function h at the x value -1. So I'm going to make a note. This is red. Evaluate the function h at x equals -1. Which means find y plugging -1 in for x. That's what it means. This is just plug it in. They're saying, hey, go to the function that's titled h, that's this one, and now plug -1 in and tell me what you get. Now here's where you have to be careful. It's piecewise function. You don't plug it into every piece, right? You don't plug it into every single piece. You have to go to the rules and see which one you're allowed to plug it in at, which is why this little graphic helps you. Where is -1 in relation to 1? I'm going to change colors. -1 would be over here. Would you agree? Okay, so which one is it shaded in? The top one, which means that's the equation you're looking at for this answer. Let me repeat that because it goes quick. Plug -1 in. You have to see, okay, which rule allows me to plug -1 in. That would be the first one because -1 would be in the shaded section, which means come to the equation and write your answer. Well, there's no x here, so your answer is just, it's 2. So h of -1 equals 2. Another way to write that, in case you need to understand what's happening here, they're saying x is -1. When x is -1, y is 2. So therefore, h of -1 is 2. That's another fancy little long way to write it. This is all I'm looking for. But if you're still trying to understand the notation and everything, you can write this to help you see where it's coming from. Now go to the next one. They're saying, let x be 1. Well, if x is 1, which rule, first or second, is 1 allowed? The first one. Why? Because it's touching. 1 would be right there. This means not allowed, correct? So that means, since it's allowed in this rule, then I go to its equation, which in this case is just the number 2. So there's no work to do. So y is 2, so h of 1 is 2. The next one, h of 4. So x is 4. Find y. Where's 4? 4 is going to fall here. Which one's shaded? The second one, which means this is the rule we're in, which means this is the equation you use, which means the answer is, well, no, plug it in. Now there is an x, so plug it in. So the answer is 4. So right here, if you want to make a note, the equation we got here was just 2. This equation would be y equals x. Well, what was x? It was 4. So h of 4, we'll plug that in and you get 4. Now looking at the graph, let me show you this. This is x is negative 1, y is 2. Look, negative 1, 2. You should land on the graph. X is 1, y is 2. Right 1, up 2. X is 4, y is 4. Right 4, up 4. So that's another way to evaluate it if you have the graph in front of you. Okay? Does that make sense? Go to the next slide and then we're stopping. Actually, let's skip around. Go to, hold this slide for tomorrow. Go to this one. This is exactly what we just did. Here is your piecewise function. This right here is your rules. Right here. This is saying find all of these. So let's break it down. You've got find f of negative 5, f of negative 3, f of 0, f of 3, f of 4, and f of 10. So this is just plug and chug, but you've got to know which rule to go to. Come up here and draw your number lines to help you, if you want to. You really don't have to draw the number line. You could just say, what am I plugging in first? Negative 5. Visualize to yourself putting negative 5. Let me make the marker thicker so you can see. Visualize putting negative 5 in place of these x's, and then which one is true? Whichever one is true is the one you use. Is negative 5 less than negative 2? Yes. If you think of the number line, yeah. Then just double check the others. Is negative 5 between, this is how you read it, it's between negative 2 and 3? No. Is negative 5 greater than 3? No. So that's a way to check yourself. So clearly I am using the first rule right here, which means that's your equation. So let me erase those. So my equation is going to be x plus 1, which means now plug it in. Plug x in. I'm just going to draw an equal sign. So negative 5 plus 1. What do you get? Negative 4. Now the fancy way to write it would be, I'm going to draw an arrow. So f of negative 5 is negative 4. Now you finish this and then let's check our answers and then we're done. Now when you get to f of 3, don't panic and run. Don't be the character from Chicken Little. Only one rule will work every time. If you're saying to yourself, well, 2 rules work, you're not reading it correctly. Only one rule should work, because remember, it's a function. it should pass the vertical line test. So when you go to plug 3 in, you have to look at it and ask yourself which one is true. It would be the middle one, and it's because of this right here. That is exactly right. So in this case, it's when x is 3, y is 5. When there's no x to plug it in, it means it's a horizontal line on the graph. If you come back to this, remember that horizontal line right here? That was because it was just a plain old number. Did you use the first equation for that one? So did you get -2? Did you find the second equation fits 0? Second rule? Yeah? 0 is in between -2 and 3. So the equation is 5. Don't overthink this, which means there's nowhere to plug it in. You're done. That's the y value. You can't plug 0 in, there's no x. It's a horizontal line. That's 3. We already said. So same thing here. This is equation 2. There's nowhere to plug it in. 4 falls in rule 3. Copy the equation. And in this case, you can plug it in, right? 4 makes a true statement here, so that's your equation. Yep. And then the last one.
You have to write that comment next to it.
Say again?
You really write that comment next to it. The comment next to it. Oh, it's next to all it. That's fine.
Oh, the comments were there just saying.
Yeah.
Find those